Sometimes when people think of innovation, they think of ivory tower academics like me and you selling out. They think about, oh, okay, you made this thing, now you're going to give it to big pharma. Oh my God, how are you going to, how do you sleep? I don't think that way. I think it's necessary to involve the private sector. You cannot build something and rely on just grants and philanthropy. If you want to help as many patients as possible, you really do have to engage. I think this aspect of innovation and commercialization sometimes has a taint to it. I think that's changing with the younger generation. I see this in the grad students, I see this in the medical students, and even the residents. They have kind of a more entrepreneurial mindset than I think generations past, like including yours and mine, and certainly the older generation. So I'm hopeful that taint will dissipate.
Welcome to 2036, the podcast, Season 3. I'm Ken Carter, professor of psychology at Emory University's Oxford College, and today I'm here with Dr. Wilbur Lam. Wilbur Lam, PhD, MD, is the W. Paul Bowers Research Chair in the Department of Pediatrics at the Wallace H. Coulter Department of Biomedical Engineering at Emory University and Georgia Institute of Technology. He is also Associate Dean of Innovation for Emory University School of Medicine and Chief Innovation Officer for Children's Healthcare of Atlanta's Pediatric Technology Center. Welcome to the podcast.
Thanks for having me.
So your research focuses on using technology to research, diagnose, and treat blood diseases and related cancers. What's inspired you to do this in this area?
Yeah, I guess it's several kind of interests of mine. Now, I've always liked kids, so that's why I'm a pediatrician. And when it comes to blood and cancer, those were really the diseases that kind of the nerdy side of me really gravitated towards. In fact, I got so nerdy that I ended up combining my training with a PhD in engineering. And that's when I really became enamored with developing new technologies, for benefiting patients. What I realized even as a trainee when I was a resident was that what was considered state-of-the-art on the scientific side was light years ahead of what is state-of-the-art on the clinical side that's used at the hospital. So I wanted to kind of fill that chasm a little bit more.
Yeah. And why is that such a chasm? Like what creates that difference between what happens in the research space, in those innovations, and what happens in the clinical space?
Yeah, there's numerous reasons, right? In fact, there's a whole term for this. This is called the valley of death. When something new is developed, some new research is being really embarked upon, it takes a while for it to really translate to benefit patients. And some of it is just due to technology itself. It takes a while to vet it. Some of it is due to regulatory issues, right? Especially when you're dealing with human health, you have to be careful, right? It's one thing for Silicon Valley to develop a new app and then that immediately goes to market. There's very low risk for that. But when you're talking about human lives, whether it's diagnosing, new ways to diagnose disease, new ways to treat disease, you really have to vet it. So there's a whole regulatory process that usually takes years, even decades.
Wow. And so what kind of technology are you developing now?
So my own lab is what's called a microtechnology lab. So we really steal the techniques that, for example, the computer chip industry uses, the electrical engineering industry has used for many decades, to make computer chips related to what's in our phones, what's in our laptops. Use those same technologies to make really tiny gadgets that are computer chip-like to study blood. Because blood goes around in our body, and the cells are really small, and they are in these little blood vessels that are basically on the same type of size as the wires in a computer chip. Wow. So those types of technologies can be used to develop in vitro models of blood. And that's what we do from the basic science side. We also are very interested in taking those same technologies and making them into new ways to diagnose disease.
Yeah. And so what kinds of conditions do you think are most likely to benefit from that kind of innovation?
Yeah. So there are too many to talk about in this one podcast, but at least I think there's a lot of potential for diseases of the blood that currently are really big problems in public health and even in our country. So sickle cell disease is one where it's basically a plumbing problem. These patients have a genetic disorder in which their blood just doesn't flow as well as a healthy patient. So we can create models to not only study this, but also help to predict which patients have poorer outcomes, which patients are about to experience a complication. So that's what I'm very excited about, especially given how there's new ways to treat diseases like sickle cell disease. And then even more common diseases like cardiovascular disease, how blood clots form. Those are all good blood clots, bad blood clots. That's what a heart attack is a bad blood clot. How do we predict when those form, and how do we study what's actually going on, and therefore what are better ways to treat those complications?
Now, you have two titles that have the word innovation in them, both at Emory and at Children's Healthcare of Atlanta. What does innovation mean to you?
That's a trick question, right? I mean, innovation. I mean, we should all be innovators, right? Here at Emory, every one of us is innovating, right? Whether we're innovating for education, innovating for patient care, innovating for in the auspices of what I do. There's an aspect of commercialization, frankly. It's about translating an invention to improve patients' lives. And in our current system, it's a capitalist system. So we have to always think about financial sustainability and think about how we can leverage the private sector and interactions with the private sector to get those technologies into the patient's hands as soon as possible and to improve their lives and clinical outcomes.
Yeah, and you're really in a really neat sort of situation where you can sort of look ahead to see the kinds of technologies that might be used for conditions in the future. So what are you most excited about that you're seeing now that could come out?
Yeah, so there's a couple of things. So I'm pretty lucky to lead a great team here at Emory. It's based at Children's Healthcare of Atlanta as well as Georgia Tech. We have an NIH-funded diagnostic center that is devoted to helping foster development of what are called point-of-care technologies. And these are tests that are done, diagnostic tests that are done not in a typical hospital setting. So there's great examples of this already that have been around for a long time. So if you know anyone with diabetes, they carry around a little glucometer. They test their blood sugar. They can do this at home. So it's a diagnostic test that's done at the point of care, done at home. Pregnancy tests, another really important one. And then even in emergency rooms, they do a lot of tests that are kind of not in the typical clinical or hospital setting. However, what I'm very excited about, and we kind of learned this is one positive aspect of the pandemic, is there's a big push towards what I would call the decentralization of disease diagnosis. More and more, there's more interest from the medical side. We're now realizing, a lot of this stuff doesn't have to be done at the hospital, doesn't have to be done in the clinic. It could be done in the communities. It could be done in the schools. It could be done in people's homes, right? We saw that. So our center was blessed to be part of this big initiative to bring forth new diagnostic tests during the pandemic. And we were pretty lucky here at Emory, such that our center was chosen to be the test validation center of the NIH's initiative to bring new tests to the market when the pandemic started. So all this comes full circle, where I think this whole paradigm is here to stay. We will see in the next 10, 20 years more and more diseases that will be diagnosed in atypical places. There's going to be more stuff that's going to be done at the schools, in businesses, in communities, in homes, and in the patient's hands. So not just with COVID, but with plenty of other diseases, even chronic illnesses.
And so what will that give us as, sure, it also helps in the side of the person who's experiencing those things, but it probably also is a great benefit to clinicians as well.
Yeah, and that's a very important point, because kind of before the pandemic, a lot of the medical community really thought, I don't know if we could really rely on the technology to work well enough to be able to put it out into the wild like that. We need to make sure that data that we get is good quality. So there's a trade-off, obviously. And once you get things into the wild, even when I do these things by myself, I mess it up, right? But taking that into account, I think that's where the calculus has shifted. The benefit of moving things into the patient's hands, where it improves their quality of life, it is way more convenient for them, and we can start to do things that are quicker now. We could diagnose things quicker. All that stuff will actually improve public health. We just need to be aware of the fact that when it's in the wild, we lose control of it a little bit more. But the medical community has certainly shifted their thoughts on this, and certainly the public has as well. Right before the pandemic, it was really pregnancy tests and diabetic glucometers. Now it's like, oh my God, we could diagnose infectious diseases at home. There's a will for that. So what's interesting is over the next few years, we'll see a lot more of this.
Now, you have a joint appointment with Emory University and Georgia Institute of Technology. What does each institution bring to the table, and how do the strengths both affect your research and new treatments for patients?
Yeah, I think the collaboration between the two institutions is fairly unique in our entire country. I haven't seen two institutions that are that much in sync as Emory and Georgia Tech. And I think a lot of it is that they both bring to the table something the other doesn't, right? Georgia Tech is a fabulous technical institute that is, however, does not have a medical school, is not attached to healthcare systems, does not have hospitals. Emory, also is a renowned institute, but it is not a technical institute per se. It is not an engineering school. So the two institutions really see each other as great ways to move forward. And that's one thing that I benefit from. My own laboratory I have a laboratory at Emory, I have a laboratory at Georgia Tech, and the guys in my lab, get the best of both worlds, where they get exposure to the top-notch medical school as well as a top-notch technical institute.
Now, for people who might not know what bioengineering is, how would you describe it to an everyday person?
Yeah. If you ask 5 different bioengineers, you'll get 5 different answers to that question. In my mind, it is really about developing new technologies to improve patients' lives. It's simple as that. So in many ways, there's many people who are bioengineers who don't necessarily have that label.
And so what about that intersection between bioengineering and medicine? Like what's going on in that space?
Again, many different directions. If you want to talk about gadgets, right? There's plenty of new medical devices, even the stuff that we just talked about from my own laboratory, new ways to diagnose disease. Medical devices will now become smaller, and there's also therapeutic medical devices. Those are steadily becoming more and more accepted in the medical community. And then from the therapeutic side, bioengineers have always been on the forefront of developing new ways to apply new biological techniques to improve therapies. So things like cellular therapies, where you take a patient's cells and you engineer them to do something new to attack bad cells or infections or cancer cells, or even rewiring the DNA of genetically altered cells. So CRISPR is a great example of how that can be packaged into a drug such that we can improve and even cure theoretically genetic diseases.
Wow. Now, there's a new building, a new research facility, the Emory's new Health Sciences Research Building 2, that opened up recently. Tell me a little bit about what that having that new facility means.
Yeah, I mean, first of all, it's beautiful, right? So it's always nice to have that beautiful building. And I think from my own perspective, what I'm very excited about is on this first floor, there's actually an innovation center where we have everything that we just talked about, infrastructures that symbolize what you and I have been talking about the last few minutes, Ken. There is a place where we can make new micro machines. So there's a whole facility there. There is another facility that is dedicated to 3D printing, and 3D printing not only just for healthcare applications, but we're also talking about 3D bioprinting, meaning we build things out of cells. So we can start to create we start to scratch the surface of putting cells together such that they can perform and act more like a real tissue. So we do that with standard 3D printing techniques modified so that instead of a resin, it 3D prints, right. We 3D print actual cells. And then we have another facility that is based on virtual reality. So what we would love to do is bring clinical trials and conduct clinical studies and basic science biomedical studies in a virtual reality space.
So it's having that technology there and the people there. Is that one of the tricks to being able to create that innovation, having that combination of people and technology in one space?
Yeah, you always need both, right? Yeah. I mean, technologies are useless if you don't have the right people with the right mindset. And I think that's why this building is so unique. It's not only a beautiful building, but also it will be housed with all these different biomedical disciplines, biomedical researchers. And we, on the first floor of that building, will have these facilities that hopefully will augment their research and start to bring these new technologies into their labs.
So which childhood cancers and related blood conditions would you most like to see eradicated or at least reduced to a manageable medical condition?
Well, I guess I'd like to see all of them, right? So again, I think I'm very excited about the prospects for sickle cell disease, where up until 5 years ago, there was only one FDA-approved drug. Now there's 4. And just in the last few weeks, we realized that there's a likely approval of genetic therapies that could be even curative. So that's very exciting. I think what will always be needed, though, is new ways to test and monitor whether or not those new therapies work. Childhood leukemia is another area that is of particular interest to mine, and also we here have in our pediatric hematology oncology division, we actually take care of the biggest sickle cell population in the entire country. We also have a very large childhood leukemia population as well. So the entire field has done wonders for kids with leukemia over the last few decades, but we still have kids that relapse, and it's those kids that need help. So I'm excited about the development of new ways to help identify which patients might be at risk for relapse and therefore need different types of therapies and helping them move forward.
Do you feel like there are some misconceptions about innovation in healthcare that people sometimes have?
Yeah, that's a good question. I think sometimes when people think of innovation, it goes back to what I said. They think of, ivory tower academics like me and you selling out, right? Mm. They think about, okay, you made this thing. Now you're going to, give it to big pharma. Oh my God, how are you going to? How do you sleep, right? I don't think that way. I think it's necessary to involve the private sector. You cannot build something and rely on just grants and philanthropy if you want to help as many patients as possible. You really do have to engage. I think this aspect of innovation and commercialization sometimes has a taint to it. I think that's changing with the younger generation. I see this in the grad students, I see this in the medical students, and even the residents. They have kind of a more entrepreneurial mindset than I think generations past, like including yours and mine, and certainly the older generation. So I'm hopeful that taint will dissipate.
Yeah. I mean, and so what does it mean to you to be at a place like Emory that can not only partner with a great public institution like Georgia Tech, but bring together these innovations in a new space? What does that mean for the work that you're doing?
Yeah, I think the opportunities here for all of us are really boundless. And again, it goes back to what you said, where you not only need the technology, but you need the right people and you need the right institutional support. And I think we have that here with these three institutions, Children's Healthcare of Atlanta, Emory, Georgia Tech, working together. And that's truly unique. And I think just the fact that we are such a large player in our state, in the Southeast, that helps a lot as well, because we have a very large patient population we can help and draw from.
Well, thank you so much for being on the podcast.
Thanks for having me, Ken.
To learn more about 2036, Emory's campaign to transform the future, visit 2036.emory.edu.